This is the video for homework exercises 14E for math analysis, transformations of a graph. The first problem we're going to do is a translation. Translation just means it moves. So if I take a graph, and this is not the graph of the example that I'm going to work, it's just a generic graph. I want that to move left 3 and up 1. So graphs, my new function is going to look something like the old function, except that each point moves over 3 and up 1. If I want that to happen, and I'm showing that in the parentheses here, I'm told that's what I want because I have a -3 for my x and I have a 1 for my y. So I need the graph to move to the left 3. If I want that to happen, when x is 1, I need to make the function think that x is 4. So I'm going to take 2 times x plus 3 cubed. That way when x is 1, I'm actually taking the cube of 4 and then multiplying by 2. If I'm going to move the graph up 1, my new y is going to be 1 higher than my old y. So if I do this calculation, I will get 2. Y would be 2. I'm sorry. On this one, it would end up being 2. I need it to be 1 more than that. Or in other words, my old y is going to be 1 less than my new y. So I'm going to put that in here. So my new y, if I subtract 1 from my new y, I'll get my old y, which is this one. So what I ended up doing, I subtracted the 3 from the x. X minus -3 gives me x plus 3. And I subtracted the 1 from the y. Now I solve for, need to solve for a function that gives me just y by itself. So I'm going to say y equals 2 times x plus 3 to the third plus 1. And to actually do this in standard form, I would actually have to multiply the binomials, which you'll be able to do in this one. I don't want to do it here because it's to the third power. And actually I can put it into Desmos to check it the way it is. And that's what I'm going to do now. I'm going to go to Desmos. And go to my function editor and put in, first of all, y equals 2x to the third. And my graph looks something like that. And the second thing I'm going to do is put in y equals 2 times quantity x plus 3, quantity to the third, plus 1. So I put in that, and I notice from my graph that the graph was originally crossing the y-axis here at this point. So, and I have actually moved over 1, 2, 3, and up 1. If you want to pause the video now, practice 1A, try 1A, and check your answer on Desmos.com. See what you get. When you come back, I will do 1B. Okay. In 1B, we want to reflect it now. Instead of moving it left or right, we're going to reflect it about the x-axis. So if I look at this, if I put a mirror here on the x-axis, what I would see is this only flipped over. So what I'm actually trying to do when I reflect it is flip it over. So it flips over the x-axis and ends up like this. To do that, what ends up happening for every x, my y is now negative. Y that was positive before is now negative. Y that was negative before is now positive. So I just multiply y times negative 1. So I'm going to say, after my transformation, I have negative y equals x to the third power, or y equals negative x to the third power. Once again, I'm going to graph that on Desmos.com and see if that actually happens. So I still have my x to the third. I'm just going to change this to x to the third. And I will change this to x to the third, negative x to the third, I'm sorry. Okay. And if I look at that, look at my graph, and I look at a point here where x is 2, y is 8, because I'm going x to the third. That point is actually now flipped over down here. X to the, if x is 1, y is 1, because 1 to the third power is 1. When I flip it, it's actually down here at negative 1. I was at negative 1. If I do that negative, it comes up here. So points that were above the axis now are below the axis. That's why we call it reflecting it. So if I put a mirror here, the reflection of this would be down here. Okay. Try 1b now. Y equals the square root of x. Try to reflect that around the x-axis. Pause the video, and when you come back, I will do 1c. Okay, 1c says it wants a vertical dilation factor of 1/2. And if we go back to our list of transformations, the transformations we just did are on there. For translation h and k, you start off your new values equal x plus h, y plus k. So the old values actually equal the new value minus this, minus h and minus k. So you plug the new values in for the old values, which is what we end up doing after our discussion. The reflection about the x-axis, it actually says the new y is just going to be the negative y. So the old y is the negative of the new y. We just plug negative y into our equation. The dilation factor, the formulas for that are down here. So we want a dilation factor in the vertical direction. So we look at the vertical direction, and what that says is that the new y is going to be the old y times k, the dilation factor, or the old y is equal to the new y divided by k. And what I'll do is plug this in for the old y. And what that's going to do on my graph, if I look at my dilation factor, when I look at my graph, if I want to have a vertical dilation factor of 1/2, when y is 2, I need to have y equal to 1. So whatever my y is, I'm going to take it and divide it by 2. So my answer, I'm going to take that answer and divide it by 2. And actually, that's what's going to show up in my problem here. So I'll have a dilation factor of 1/3. So I will take y equals 3x minus 6, and I'll just multiply all the y's by 1/3. If you go with the formulas say to plug in y divided by 1/3 equals this, and then you multiply both sides by 1/3. Either way you want to do it, whether you use the formulas, start off with y divided by 1/3, and then multiply both sides by 1/3. Or if you just like to multiply this side by 1/3, that's fine. Either way, you end up with y equals that should have been a minus 6. Y equals x minus 2 when I distribute my 1/3. Okay. And once again, I'm going to check that on Desmos.com. And I will plug in the original equation, y equals 3x minus 6. So 3x minus 6. And then I'll plug in my new equation, y equals x minus 2. And if I look at that, my original equation in the green, if I pick a point where x is 4, y is 6, and I look at my new equation, I want to be 1/3 of that, and I'm actually at 2. When x is 0 on the green, 1/3 of 0 is 0, and I see on the red I'm also at 0. If x is 0, y is negative 2. Actually, it'd be negative 6 on the green. It ends up being negative 2, which is 1/3 of 6. When x is 5, y is 9 on the original, and on the new one, it is 3. So I have accomplished my goal of reducing all of the y values by 1/3. If you want to pause the video now, practice 1C, then I will go on and we can talk about 1D. Okay, now that you have practiced 1C, 1D wants us to reflect it on the line y equals x. And once again, I'm going to use my example function. This is not the function we're going to be working with. But I want to reflect this around the y equals x line. So this line here is y equals x. If I want to reflect that, I'll put a mirror here. Anything I see down here is going to be up here. So if I reflect it around this line, this point is now going to be this distance up here. This point is going to be this distance up here. And this point is going to be on the line still. It's 0 away from this line. It's going to be 0 away from the line again. And this one is actually going to end up the same distance, but down here. So actually what I'm going to do is end up flipping the x and the y. So my y is going to end up over here. So what was x is now y. What was y what was y is now x. Y was originally 2, now x is 2. And that's actually the transformation that they show in the table under reflections. Your reflecting around the y equals x axis, your new y, x is the old y, your new y is the old x. So the old x is the new y, the old y is the new x, and that's what I plug in. So for my x value, my old x, I plug in the new y. For my y value, I plug in the new x. And with this equation, I'll just do that this way. X equals 4 times y minus 3. So that's pretty straightforward. But we need our equation in terms of y. So I have to add 3 to both sides, which gives me x plus 3 equals 4y, or dividing both sides by 4 and flipping it around, I'm going to end up with y equals 1/4 x plus 3/4. Okay. And actually, just for putting it for the purposes of putting it into Desmos, I'm going to leave that as 1/4 times x plus 3. This is actually the proper way to do it because standard form does not have the parentheses. But in terms of graphing it and checking to see if that actually gives us a reflection, this will work just fine. So I'm going to go back to Desmos and put in the old function. So y equals 4x minus 3. And my new function ended up being y equals 1/4 times x plus 3. So I'm going to say parentheses x plus 3 divided by 4. Since I don't want to multiply by 1/4. And if I look at those two numbers, or those two functions, those two graphs, I see that my original graph, 4x minus 3, goes like this. And if I put my y equals, let me actually do that in Desmos. I'll go back to the equation editor, and I'll put in y equals x. And look at that. The blue line is y equals x. And you'll notice that this line is the same distance as this line away from x. So I've accomplished my goal of just flipping it over by doing those mathematical adjustments. That's question D. If you want to go ahead and do question D the same way, reflected on the under a reflection on in the line y equals x, pause the video and come back, and I will do E. Okay, now that you've done 1D, let's take a look at 1E. 1E now wants a horizontal dilation factor. Horizontal dilation factor is going to be a little more challenging. Actually, the horizontal dilation factor, it's the same idea as the vertical dilation factor. What's challenging now is that we have a quadratic equation. But our fundamental idea is the same. If we go to our tables, our dilation factors, the horizontal dilation factor, that just means I'm going to multiply everything by My new x is going to be the old x times k. So in this case, horizontal dilation factor of 1/2. I want my new x to be 1/2 of the old x. So that means the, sorry, my old x, old x is going to be, sorry, the new x is going to be half of the old x. So my old x is going to be the new x divided by 1/2. So I'm going to take x divided by 1/2 and plug it into the old x. So wherever I see x, I'm going to put in x divided by 1/2. Before I do that, though, I'm going to go over here and make a little note. X divided by 1/2. I'm going to do an equivalent fraction. I'm going to multiply the numerator and the denominator times 2. Say that equals 2x. So I'm actually going to plug in y equals 2x. I'll square that, plus 2 times 2x minus 3. Okay. Now getting rid of the parentheses, 2x times 2x would give me 2 times 2 times x, which is 4x squared. 2 times 2 is 4x, and minus 3. So I have a new equation, which should end up having all of my x values half of what the old x equation had. And I'm going to check that by going to Desmos.com. And I will put in the original equation, y equals x squared plus 2x minus 3. So x, use the caret for the squared, x squared plus 2x plus minus 3. And I notice that gives me a parabola, as I would expect. The new one is 4x squared plus 4x minus 3. And if I look at that graph, I think I put in a space. Oh, I put a V instead of an X. That's what it was complaining about. If I look at that graph, first of all, I'm going to drag it up a little bit. My original graph is the green, again, the black. I keep changing the colors. The original graph is the black, and the new graph is the blue. So for every x, if x is 1, the new x is 1/2. When x is 2, the new x is 1. When x was 0, the new x is 0. When x was -2, the new x is 1. X was -1, the new x is -1/2. So for every x value, it's 1/2 of what it was before. So I did accomplish my goal. The last one I'm going to do, after I pause the video and you work on question 1E, is question 1F. So pause the video now and do question 1E. Now that you've done question 1E, I will do an example for 1F. And 1F actually just wants a reflection in the y-axis. We did a reflection around the x-axis. Reflecting it around the x-axis Once again, this is that same function, which is not what we're doing. It's just an example. We reflected it around the x-axis. We just flipped it over, so all of our x's became negative. If I want to reflect it around the y-axis, that means I'm going to flip it over this way. All of our y's are going to change sign. So my y was originally here, now it's going to be here. Y was originally here, now it's going to be here. So I will just do that. And once again, that was shown in our table. So for reflection about the y-axis, I'm sorry, I think I said the y's. Reflecting about the y-axis, but what's going to happen is my x is going to become negative. If you reflect about the y-axis, the x becomes negative. So for y equals 2, x was 4, now it's negative 4. I think I said that backwards, I apologize. And that's what shows up in our table. For reflection about the y-axis, you have your new x is your old x times negative 1. And as a result, your old x is your new x times negative 1. So when I plug in my new x for my old x, I'm going to have equals negative x squared plus 3 times negative x. And that gives me y equals negative x times negative x is going to be a positive x squared, because a negative times a negative is a positive, but when I take negative x times 3, I'm actually going to have minus 3. So I'll have x squared minus 3. And as always, I'm going to plug that into Desmos.com. So I start with y equals x squared plus 3x. And once again, that's a parabola.